So here we have the water, or the balloons in the bottle of water. So the bottle represents the chest cavity. The mouth of the water bottle, so this black balloon represents the lungs, and then the gold balloon represents the diaphragm. So total lung capacity is the total amount of air that can be held in the lungs, sum of TV, ERV, IRV, and RV. Residual lung capacity is the amount of air that remains in the lungs after maximum exhalation. Vital lung capacity is the sum of TV, ERV, and IRV, which is all the volumes that participate in gas exchange. And lastly, tidal lung capacity is the total amount of air that can be held in the lungs, sum of TV, ERV, IRV, and RV. So now we will measure my tidal lung capacity and vital lung capacity to determine my lung capacity. So stretch out the balloon several times. I obtained string, a balloon, scissors, and I don't have a ruler, so this is just gonna have to work. Okay, so now we will take a balloon. We're gonna measure the tidal lung capacity by taking a normal breath in, placing the balloon on my lips, exhale a normal breath into the balloon. Okay. Okay. So that was 5.5 inches. So that is 13.79 centimeters. So we will repeat those steps 4 more times for a total of 5 trials. I missaid that. We need a total of 4 trials because 5 will be our average. So on average, it came out to be 14.3 centimeters. So now we will measure vital lung capacity by taking a big breath in, place a balloon on your lips and exhale as much breath as you possibly can into the balloon. So force as much air into the balloon as possible. And then pinch the open end of the balloon, place on the table, and wrap the string around and measure again. Okay. So now I will measure the biggest part. Oh no. Okay, so the biggest part was 20 inches long. Now we will do that 3 more times to a total of 4 and then average it out. So the average for the vital lung capacity was 50.13. So now we're going to determine the averages for the tidal and vital lung capacity by taking the balloon diameter to the third power times pi divided by 6. So now we will answer the question. So how did your tidal and vital lung capacity differ? Explain why you might see that difference. So my vital was definitely a lot higher, but that was because I was pushing all the air possible out of my lungs into the balloon. And the tidal, it was just a normal breath. How might an athlete's vital lung capacity compare to a non-athlete? So an athlete would have a better lung capacity because they are used to the exercise. They're regularly practicing and their body knows what to expect. How could a habit like cigarette smoking affect your lung capacity? It could definitely affect your lung expansion and how much air you are able to inhale and exhale. And now we will do the post-lab questions. So the first one is, what is the function of the respiratory system? So it is to facilitate gas exchange and bring oxygen into the body and remove carbon dioxide. So the next question is, how does the diaphragm function in respiration? So when the diaphragm contracts, it flattens and moves downward. And then when it expands, it creates a way for drawing air into the lung. So I would show you, but I broke it. So when you pull down, it's the lungs up here are expanding. And the third question is, how does the alveoli function in respiration? So they facilitate the transfer of oxygen from inhaled air to the bloodstream and remove carbon dioxide from the blood into exhaled air through diffusion. Describe how the respiratory system is closely linked with the cardiovascular system. So both systems work together to deliver oxygen to the body's tissue and remove carbon dioxide. So the alveoli is putting in the oxygenated blood to the bloodstream, and the cardiovascular system will deliver the blood throughout the body. The last question is, what factors would influence respiration, and explain why? So there are a lot of different factors. So physical activity, health conditions, environment conditions, stress, physical activity, smoking. There's just a ton of different things that can play into your respiration. So for example, like smoking, that would not make your lungs be able to inhale as much air as they can, and you're not able to breathe as well.